Okay, good morning. Sorry I had to cancel class the very last second today. I had something come up and I have to take my wife to the doctor. Anyway, we'll be doing a little more coding online with our jazz music. It's going to be coffee this morning instead of wine. What we're going to do today is we're going to start by fixing some of the errors in the example that we did last week and fix it turned out that it was a shader problem that wasn't letting the model get dark when the lighting got dark. I should have figured that since we're talking about light and shadow, and that's exactly what shaders often do. The answer's kind of in the title there. So, yeah. So that's what I figured out. And so we'll fix that dragon statue thing first to work exactly how we want, and we'll add in some on-screen displays that will report what the current lighting situation is on the screen. Fix another couple little things. And then from there, we're going to go on to add some new assets to the program, and I want to basically turn it into this monster game in preparation for Halloween. So we're going to make a dark monster dark monster experience that basically a monster you can instantiate a monster or summon him at a certain location with your application, and then if you turn the lights off, he'll get closer to you every time you turn the lights off. So that'll be really fun. All right, so let's start by picking up where we left off on our light estimation patch. So go ahead and open the thing we did last week. I have a squeaky chair, so bear with me. Okay, so the first thing we want to do, as I mentioned, it's this shader is the reason why the dragon asset, this dragon here under prefabs, placed a dragon. The reason why this wouldn't react to the in-scene lighting is because the shader that was being used for it doesn't use any real-time lights. So we need to change that. And it's a shiny object, so there is a shader in here. If you go to, you double click on the dragon, so it brings it up in the prefab view, which has this blue background, right? Then if you click over here, so this is our parent object, place dragon. This is the child object, this prefab, and in here is a shader where that says legacy shaders reflective bumped specular. Change that to mobile bumped specular, and then it says right there one directional real-time light, and that's what we want. And you can see it goes black, and that's because the current lighting in the scene is dark. This is kind of what it will look like under full light, and this is kind of what it will look like when the lights are off. This is the scene lighting toggle here. All right, so we got that now. That's the first thing. That should, if we just compiled here, and you can if you want, it should work like it worked before, except for it'll get dark when you turn the lights off. You will notice, though, that the dragon is often darker than you'd like, because it may be dark, it may be dim in your room and not brightly lit, but the camera is gained up because it does that automatically. And when that happens, the element doesn't seem to match the lighting in what is displayed on your screen, even though it probably matches the dim lighting conditions that are actually exist in the room. So we're going to add some functionality to compensate for that here in a minute. But first, let's fix some other issues with the code. So go into your, let's see, which code is this? This is your, go into the main, go back out of this into the main scene, and the place drag drop script that we have attached to the AR session origin, let's open that code. All right, the first thing that I found out, and it kind of happened yesterday, but it didn't seem to matter too much, but it was automatically placing the object without me actually touching the screen. And I figured out what happened is if you look that we run this code when touch count is greater than 0, and here's the opening bracket for that, and here is the closing bracket for that, and then we do this raycast. So that's what was causing it to spawn, is that it wasn't, this code here should be included inside this bracket. So let's do that. So cut, highlight all this code, cut. I'm going to get rid of my extraneous spaces here, and then I'm going to add a line here and paste this in here. And just to make it a little cleaner, I'm going to add an extra line there. And so that should fix that. And let's see. Next, the problem we had, all right, so save that. The next problem we had was in our canvas pinning. So if we go into game view, where is our canvas? If you hit F for frame select, there it is. Okay, go into game view. I don't even see anything. So one thing you want to do is when you're working with UI canvas, is to preview it in the game view really quickly, and you can do that by going into game view, and then here where it says free aspect, change that to a screen, especially if one you're going to use. Let's just for now, let's use iPhone portrait, and there we go. So that's what we saw on an iPhone, and these buttons are kind of high up and they're too big. There's some issues with them that we need to fix. First, we want to pin them down to the bottom, and then we want to fix their scaling. And it's actually not that hard. We don't have to redo them, and we don't really have to change every single button. We just need to adjust some things. So go back to your scene view, and with your canvas object highlighted, go over here where it says canvas scaler. And the main problem we had is that we were using constant pixel size, and we really want to change that to scale with screen size, and that'll automatically adjust it to fit the screen. So now if I go back into the game view, you can see now it fits perfectly. It's still too high, but it fits perfectly. So now we just need to slam this down to the bottom of the screen so that it's not in the middle of what we're trying to do. So we got that. There's a couple other things we want to do. You can also see it's on portrait. I can change this to landscape, and now it disappears. And that's because of this over here, where it says match width or height, and it's set to just match width. Make sure this is set to match width and height. Put it to 0.5, and change the reference resolution from 800 to 600 to 1920. See, now it comes into view by 1080. Okay, that's the first thing. And I can go ahead and change this back to this. And so this, now it looks good in landscape, but it doesn't look great in portrait. So now we just need to move these a little bit. So let's move the options panel down. So go to this options panel object here, and the first thing we want to do is set our anchor point. Right now we're set on a position relative to the center of the screen, and instead we want to have a position relative to the bottom middle of the screen. So this is our anchor point here. Click down to the bottom middle guy there, and now you can see it adjusts these values based on what you have. So like if this is set to the middle, this is at -346 from the middle. If you set it to the bottom, it's at +614 on the Y. Set this down to like 150. See, that looks so much better. And you can leave that stuff alone. I think that's all we need there. Let me see, anything else? No, that fixed that. All right, cool. Now, new thing, new problem. Down here in these buttons, notice it says toggle shadows, toggle planes. I'm not sure, maybe you were better, maybe you didn't have this typo in yours. Maybe yours actually said toggle shadows, toggle lights, and toggle planes, but regardless, we have code that changes the title, the text here, and so we should conform to what the code is going to actually change it to. Otherwise, it'll say one thing, and then when you click on it, it'll say something different, and when you click back, it'll say something different than what you had in the first place. So let's fix that. So first of all, toggle shadows button. Instead of saying toggle shadows, so if you click, we're opening the options panel over here, and then we have the toggle shadows button, the toggle lighting button, and the toggle plane button. On the toggle shadows button, if you open that up, there's a text object, and this is where we set the text, and it's set to toggle shadows right now. We're going to change that to disable shadows. So yeah, and then here, toggle lighting button, change that to disable lights. Okay, and toggle plane button, disable planes. Great. Now these look the way they should. Let's build here. Let's go ahead and build. So that'll fix that. Go back into your scene view. Sorry, I got a runny nose. All right, so we're going to go ahead and say build settings. You're going to choose your platform. You should have your build settings from the last class already set up for ARKit or ARCore. So go ahead and choose your platform. If you're on the wrong one, you go down here and then say switch platform. I'm going to build in iOS. And so let's build, save over. I have a builds directory that I created. And if it's iOS, I'm going to call it iOS. And if it's Android, I'm going to call it Android. And you just say save, and I say replace. And that'll build. All right, so it's done building. We're going to open this in Xcode. Excuse me. Okay, so make sure you have your device attached. You have your device selected up in the list up here. And click on the top level Unity iPhone, go to your signing, and set this to your name. Oh, you know what? I forgot. So this is, I guess it doesn't matter. One thing to know is that when you set a program a company name and you build a profile for this, see, this one expires today. They only give it to you for a week, so I should go back actually and build this again with a different company name. I forgot to put that in my notes. So here under build settings, player settings, I'm going to start doing this for my company. Instead of calling it ARFProg, I'm going to call it week 6. That way I can just generate a new one every week. So yeah, whenever you build one of these applications, unless you have an Apple developer account, it only gives you a license for a week, and then it will expire your signing. So let me save this, and we'll build again. Sorry, wasted time. Build, save, replace. It'll only give you a week on that company name, and then if you want to use the app again, you can. You just have to rebuild it under a different company name and generate a new signing certificate. It's kind of an intentionally annoying thing that they do to keep you to try and force you to buy an Apple developer account for $100 a year. There's also, if you're going to actually deploy apps to from the App Store, so say you have a gallery showing and you've created this iPhone app that runs really well on most people's iPhones, and instead of you handing them a device with it already installed, you just ask the person to download it from the App Store. That would require you to have a Apple developer account, which costs $100 a year for a personal account. That would also allow you to have a signing certificate that you could renew, and it wouldn't expire as long as you renewed it every, I don't know how long, I think every year or something. All right, so we're back. Now it says bundle identifier COM week 6 lighting estimation, and if I go into my signing capabilities and I put down my personal team and I look at my provisioning profile here, it says I have 6 more days. I started this yesterday, so there, that's better. Okay, so now we're going to build. Let me make sure my iPad's turned on. Okay, build. So the homework for next week. So yeah, I hope you got your assignments done for today. Unfortunately, because I had to cancel class last second, we won't get to look at those today, but we will look at them next week. And I'd like you to do one more thing to your projects for next week, and that is to add lighting estimation to your project. So whatever you did, just add lighting to it, and I'd like it. You don't have to necessarily display the lighting information like we're doing in this project, but I would like when you turn the lights off for your object to get dark, and when you turn the lights on, your object to be lit. So let's see if we can show you what we have so far. So if I think this started working again, which was great. I don't know, it must have been in an update. They figured out that they accidentally broke it. New movie recording. Nope. Jackson's iPad. There we go. Ugh, no, leave me alone. All right. So we have this light estimation app, and if I there we go. So now we can create a plane, and it doesn't just automatically spawn the dragon. And I can tap on it, and it spawns the dragon. And you can see, as I said before, the lighting conditions in here are a little bit dim. Let me go ahead and disable planes. are a little bit dim, so this dragon is very dark. But you can see that he is there, and if I try to cheat the camera by putting something bright in front of it, you can see that it does get brighter when the camera value gets brighter. So that's working. And if I cover the camera, you can see it goes dark and it'll disappear instead of being superimposed over the blackness. So that's working. Great. Okay, so continuing on from here, that's awesome and it works. We're going to add the value displays to the, sometimes the buttons just disappear. I don't know what's, there we go. The value displays to the canvas. So first thing we want to do, there is some, in the code that you guys downloaded from the website last week, there is already the functionality to update the lighting value text. We need to actually add that text in the screen up here. But for now, let's go ahead and adjust the code so that it will be able to change those values displayed on the screen and show you what the current lighting conditions are. So our light estimation script is in our directional light object down here, light estimation script. And let's see, first thing we want to do is uncomment some of this code. So this text field, we're going to uncomment the serializer field, uncomment this private text brightness, uncomment that, and that, and that, and that. So this will have a field for brightness value, temp value, color correction value, which actually won't work with iPhone. It works with Android color correction. iPhone only will give you color, temperature, and brightness. And what else? Oh, these down here, brightness value text. Uncomment these. This here, I don't know what that was. That was something I was thinking about doing and didn't need to do. Get rid of that. There's another thing going on here. This sets the brightness, the current light intensity to the brightness value, and so does this. So let's get rid of both of these lines here because they're redundant. That was because I was wondering why the lighting wasn't working, and it was really that shader problem on the object. It wasn't the code. Okay, so now we have that. Is there anything else? Yeah, I did that. I did that. Okay, great. Now we need to go ahead and save this. Go back into the scene, and we're going to we need to make our UI objects in the canvas. So we don't want it to be part of this option, a child of this option panel, because then it would be glued down at the bottom of the screen. We want it to go away, iTunes, leave me alone. We want to create some just inside the canvas. So in here, create UI text, and let's set up one of them and then duplicate it, because that'll be a lot faster than setting up all three at the same time. So let's call this first one brightness value. Actually, make it all one word. Probably doesn't really matter actually, but that's what I did in my notes. All right, we're going to change the font size to 40. We're going to change the font color to white. All right, and we're going to change this this anchor to top left. And let's see. Okay, and then let's see. Let's go ahead and put some text in there and put in brightness colon space 0. Okay. Now, why don't I see it? Oh, there it is. Why is it invisible? Alpha's up all the way. What happens when I go into game view? No, it's still not there. All right. Oh, I know why. It's because the box isn't big enough to fit the text. So change, as soon as I change the height of this box to 50, then all of a sudden it comes into view. But it's not wide enough, so let's make it 500 in width. That's a little bit wider than we need, but this value sometimes can be a bunch of like decimal places, so we want to have room to hold all those decimal places. And now we just need to adjust this. If I change this position Y up to 0, then you see it there, and this position X to 0, you see it over there. Frame select, there we go. So let's move this so that it's inside of this white border. I think it was good for me at position 275 and -60 on the Y. There we go. All right, that looks good. All right, so we got that one. Now let's go ahead and duplicate this and duplicate it again. Change this one to the name to temp value and change the text down here to color temperature. There we go. And all you have to do is adjust this Y. And I found that increments of 60 works really well. So this is -60, so I'm going to make this one -120. Okay, and then go down to this one and change its name to color correction value. And you can change the text to color correction 0 and 60, 120, 180. Great. All right. We forgot to populate those text objects into the... Yeah, I know your build succeeded, but it's not going to work. All right, so in your directional light, we have these brightness value, temp value, and color correction value. And we need to... What do we need to do? We need to take these brightness value, temp value, and color correction value text UIs and drag them in there. Brightness, temp, and color correction. Otherwise it won't work because it won't be updating them. Alright, build again. Annoying. Okay, so let's take a look at that. And so now you can see that brightness value, and that's kind of why, see, it's only like 0.2, 0.1 in this room, and that's really why it's so dark. And if I put like my laptop screen in front of it so that it looks at something brighter, you can see that that jumps up to 0.5, and the statue gets a lot brighter, right? So what we want to do now, I think, is add something to compensate for this, because that's just too dark. It just doesn't match the room very well, because the camera, as you can see how noisy the image is, the camera is getting gained up, but the object is not. So we're going to compensate for that with some extra code. All right, so we're going to add a brightness multiplier slider. So go back into Unity, and this will be a child object of this options panel. I'm going to drag this below my values because they're above it geographically. All right, so in your options panel, we're going to add a UI slider. And go ahead and rename this brightness slider. Okay, frame select. There it is. Okay. So that's kind of small, especially with my fat fingers. So I want to change its size. Also, I'm going to change its minimum and maximum value. I don't think we'll need to get darker. You can always go back and change this if you want. I don't think we're ever going to need to get darker than the current lighting condition. So I'm going to say minimum value of 1. And then I found a maximum value of 10 gives you a lot of play in your ability to make things brighter. All right. So then let's adjust some scaling on this. So what we want to do really is change the width and height. So right now it's 160. Change that to 500, and change the height. No, you can leave the height as 20, and then I think you just need to change the position to be like 128 and Y position of 50. That kind of puts it in a good spot right there. And let's see what else. We're gonna want some text above this. So let's just duplicate our options text here and rename this to brightness text. And let's see, on this we want to change the font size to, oh, I didn't put that in there. I think the font size was 25, and the position here was 128. Yeah, nice and right in the middle there. And a position Y of 73. And that doesn't look right. Oh, but the height is Y. Change the height from 50 to 30. Yeah, that looks good. Yeah. And now just change this from options to brightness multiplier. Oh, need to make it wider. Just make it 500 wide. There we go. Brightness multiplier. Okay, so currently this slider won't do anything unless we need to add a multiplier to our directional light script, our light estimation script. So we need to create a public float. Let's see. I did it right here. I said public float. Call this brightness multiplier, and I went ahead and give it an initial value of 1.0 f. Okay, and then when we use our average brightness down here, current intensity equals arg's light estimation average brightness dot value. We're going to multiply that by, whoops, not x, by brightness multiplier. Okay. Oh, just by the way, if you're wondering what this is, this $ business here, that is called string. It's a way of formatting strings. It's called string projection, and it's a way of editing the string with an argument. So this is the argument. It's pulling the average brightness value, and it's replacing the text after brightness : space with whatever that value is. Okay, so that should work as far as making the brightness multiplier. What else? Okay, so save that. Go in here. We're going to have to, in our effects manager, which is where we have the all these button handling. We need to actually handle how the slider works as well. So open the script for effects manager, and let's see. We need to make a new up at the top under default light. Just go ahead and copy this. We're going to have another serialized field. And private, instead of this being light, let's make this a slider. And let's call this B mult slider, because it's the brightness multiplier. All right, and let's see. We need to load the lightness, the light estimation script into this as well. We need to call that that class. So let's do that here. Serialized field and private. You can get rid of this light estimation, because that's the class that we defined and have attached to our light, and just call that light est. Okay. Now down here where we add these listeners, this is what actually will look for changing values in the buttons, or in our case the slider, and execute a script that you define here with a void function. So let's go ahead and add a listener for that. It's going to be bmultslider dot on value changed dot add listener, and then the script we're going to call it set bmult. It's going to throw an error for right now because we haven't defined this yet, but we'll define it right now. So down below this, void set, what is it? Capital S, set B mult. Oh, not a semicolon. Open close parentheses, and actually inside this we're going to have a local variable called float B mult. Okay, and this is a really simple function. All we're going to do is light est dot brightness multiplier equals B mult slider dot value. So when a value has changed on this slider, it runs this function, and this function takes that sets the brightness multiplier variable in our light estimation script and sets that to the slider's value. That's what's happening here. Okay, so save that. And now let's go back to the editor, and this time we're not going to forget. We're going to go ahead and make our references. So do we need anything in here? No, we already did that. Down in Effects Manager, we need to do a couple things. We need to drag our slider in here into our B-Mult slider. And so then that says brightness slider. And we need to drag directional light into the light estimation to get that direct light estimation script reference set. Class reference set. Okay. Is that it? Yes. Save and build. All right. Let's take a look at that. So now I have this dark statue because the light brightness is only 0.06 right now, but I can slide my brightness multiplier up and adjust it till it feels like it matches the scene. And then I can, if I shade the camera, it goes black. See that? It responds pretty quickly too. So that's cool. That works great. All right. All right. So that is all we need to do for that statue. But now we want to do the part 2 of this, which is to create this dark monster game. Let me just show you where I got the idea from this. This is not my original idea. I saw it on this AR. This is an AR Core light estimation tutorial. And so I kind of reproduced what this guy did in AR Core with AR Foundation, so you can do it on iPhones. It's a great idea. He makes the monster disappear, but we're going to have it still be visible, but we are going to reproduce the the fact that it changes directions. You guys could probably figure out, oh no, what?
Welcome to Edison Electric. Alternating current, what's the transmission voltage? 270,000 volts. What's the...
So every time he turns off the light, it gets closer. So that's what we're gonna basically accomplish on this dark monster portion of the class. All right. So first thing we want to do is we want to import a monster asset. So go to the asset store. We're not going to use the one that you saw in that video, but we're going to use one similar. And search for assets and search for monster. And go over here to free assets. I assume you don't want to pay for it. I certainly don't. And the one I like the best is this green Hellboy looking monster down here. And go ahead and click on download, and then when it's downloaded, click import. And go ahead and import everything. This monster is cool because it has animations built in. It has a state machine. Although we're really only going to use the idling state of the monster. And right now it's just going to like teleport closer to you every time you turn off the lights. But you could probably figure out how to advance the state machine so that it actually just walks toward you. That would be an interesting project for somebody to do. Okay, I think we got it now. So it's here under character monster. And if you click on prefab, here's the monster. And if I double click that, there he is. Now, see, he's backwards. I think it's this one's set up to be like a player controller, which usually your player is going to be facing the same way as the camera instead of facing the camera. We want to turn that around. So the easiest way to do that is to simply create a new child object of this parent monster object. Here we're in our prefab view with the blue background. So create empty and name this, you can just name it monster as well. Okay, now select everything above it, not the parent obviously, but all these other child objects, and drag them into this to make them children of this object. So now we have this monster, which is its registration position, this monster, which we'll use to flip it around, and then all of the children objects. So this monster, go ahead on rotation, add a 180-degree rotation on, whoops, that's position. 180-degree rotation on the y-axis. And now he's facing you. Okay. Scary monster. All right, cool. Let's see. Oh, If we want to be able to drag him around, we need to have a collider on the object, because that's the way our tap script works. And we also need to put that placement object script, simple script, inside the object that has that collider. So it's best to put your collider in the same object as what has a mesh, so that the collider can just automatically size itself based on the mesh that's in there. So let's just click on this body mesh. I'm going to add component and just use box collider. So go down to physics, box, is it phys? Yeah, just physics, box collider. We don't need it to be too fancy. And if you click on edit collider, you can see that collider, and they just made it the same size as this mesh cube area here. So that's cool. We're going to need to now also, so over here in our assets, go to the scripts and find that placement object and drag that onto the body mesh so that it adds it below this box collider, because we'll need that if we want to actually move the monster around. Okay. And if we go back to our scenes, there we go. And if we wanted to see this monster and just kind of preview it without building the application, I could just drag the monster into our hierarchy, and that'll put him there. You'll notice the scale of the UI is huge compared to the scale of assets, but that doesn't matter because we don't care about the UI right now. We have the monster here, and if we want to see it, we can make sure that the camera is in a position to see it. If you click on the camera here, see there's nothing in the preview, and that's because the camera is sitting right at this guy's toes, so we can't see it. So if I were to grab this monster and drag him backwards a little bit, go back to the camera, now you can see his legs because the camera's sitting on the floor, but I could drag the camera up until the monster is in the frame. I could even back the camera up a little bit. There we go. Maybe move it down. And now if I hit the play button, we should see the monster do his thing. Now, I believe the way they have the state machine set up is he goes through all of his actions. So first he did his idle, then he does his walk, then his run, then his jump, then his attack, then his feint, and then his die. And then just walks out of the frame. So we don't want it to do that. So we need to edit the state machine for this. First of all, let's get rid of it from the scene. Get rid of that, delete, and then the AR camera, let's put this back where it's supposed to be at 0, 0, 0. Okay. So go back into the prefab for the monster. So it's over here, character monster in your assets, prefab. Right on the top, actually, if you go to the character monster, you see this? This is the monster controller state machine. If you click on it, it does this kind of cool node-based programming system. So as you can see, the way that this starts an entry, goes into its idle stage, and then does walk, run, jump, attack, get hit, dead, walk mech, and run mech. Not even sure what that means. But we're just going to break this connection between idle and walk. So can I just delete it? I don't think I can. But what I can do is over here, transitions, idle, walk, you can just hit the minus key there and it deletes that. Now I need to loop this idle, otherwise it'll just run through it once and then he'll be motionless. And all you have to do there is say make, right click on the idle and say make transition. And that will What's going on? That should give you an arrow. Make transition. And then click on the idle. So now you can see this arrow here that points back to idle, and that will make it loop. Okay? So that will loop the monster in his idle state, so he just does his little bobs, head bobs, and his arms flex and stuff. It's nice and scary. So now let's go and let's edit the texture, the shader and the textures, so that it has that real-time light texture. So if you click on materials, not texture, materials, and you double-click on this material one. Actually, you don't need a double-click, just a single click. Over here on shader specular setup standard, change that back to that mobile bump specular one directional real-time light. It will make the monster kind of shiny, but I think it's not bad. He looks kind of slimy this way, which I think is kind of cool. So if you double click in the prefab, bring me into my prefab view. Hello. There it is. You can see he's kind of shiny, kind of slimy, but that's like a super high lighting condition. Under a lower light, it looks pretty nice. Now the one thing I want to do though is I'd like his eyes to glow. So right now, when there's no lights at all, like that, you don't get anything. It's just a black silhouette. And what we could do is the mesh for his eyes, which is independent from the rest of the model, we could set as a different material that has a different shader attached to it. So under materials, let's just duplicate this material. It's not in the list, but it's Command D. And material 2, we could just rename that to eyes. And on the eyes shader, change that to mobile unlit. That way, this will, whatever we set to this material, will ignore the lighting. So he'll have glowing eyes. Now, if we go into our monster, and you find the bigger hierarchy, which is somewhere, where is it? Where's his eyes? All right, hold on. What's going on here? I need to find in here, in the list somewhere, is an eye, his eyes. There it is, eyes mesh. Wow, it's way down under Monster Hub 3. Eyes mesh. So this eyes mesh, down here, change this material, and you do that by going back to your materials directory and drag the eyes material onto the eyes mesh, and it will replace that with this mobile unlit. Now when I click this lighting, scene lighting, you can see they have it highlighted right now because of so he looks like he's got glasses on. But there, that's what he'll look like in the total darkness. His eyes will glow. And if I wanted to, I could go and edit the texture of this and make his eyes a different color. I think blue eyes are fine for now. All right. So now we need to adjust some script stuff. So go back to your scene view and your directional light, and open the light estimation script. And we are going to, let's see, first of all, where we have this brightness multiplier up here, we're going to basically create a threshold for what we consider dark. So make a public float and call this dark threshold. And I found a good value was like 0.04 F. Okay? And then we're going to evaluate whether the value is below that threshold, and then set a bool called isDark. So public bool isDark, and we'll set that to either true or false. It'll be true if it's dark. It'll be false if it's not. All right, and we're going to add some text to this, to the display there. That will tell us, that'll put on the screen whether we're evaluating the current level as dark or light. So under color correction value, let's actually just copy this, paste that, serialized field, and it's text also, but we're going to call this one dark light. Okay, now under our light estimation, we need to do a little bit of logic here. So light estimation average brightness, we're going to set our isDark bool. IsDark equals this value here, args light estimation dot average brightness dot value. Right, that's coming from our light estimation average brightness value, as it kind of says there. And we're saying that if it is dark if that value is less than our dark threshold. Okay, that'll set that bool, and then we are going to set the text. So we need to say, and that text here we defined as private text dark light. So dark light dot get component in children. Yeah, get component in children and text open close parenthesis dot text equals, this is the same logic that we used in to set the button texts, equals, this is ternary, so equals isDark question mark. This is ternary style logic. So if it's true, it'll print dark, and then you separate the colon for the other case. And if it's false, it prints light. Okay, so this is a way of, it's a shorthand way of having two different conditions based on whether something is true or false. If it's true, it does this condition on the left-hand side of the colon, and if it's false, it does the thing on the right-hand side. So that'll set that text as either light or dark. Okay. And that's good. Save that. Go back in. And let's see. We need to go to our canvas again, and we'll add this text value. So let's go ahead and just duplicate the color correction value, because that was the furthest down. Let me frame select. Ugh. There we go. Color correction value, duplicate this, And I'm going to drag it up and rename this dark light. Okay, and change the text, just call it light for now, because that would probably be what we start with. And now drag this down. It's on 180, so add 60 to that, to 240. There we go. All right, now let's not forget to drag this into our script to set this reference. So the script is under our directional light. We now have this dark light field down here with none in it. So drag dark light into this. There we go. So that will set that text. Feel free to build whenever you want. Stop the video and build if you'd like to do iterative builds. I'm just going to push through until we're done with this to save some time. Okay, so let's see. Now we need to adjust the code in the place drag drop, which is in our AR session origin object. And let's see, what are we doing? Oh, right, we need to basically add a bool that'll keep track of whether it was previously dark on the last frame, because we don't want it to just constantly move him forward when it's dark. We only want him to move forward one frame, and then it has to be light again and then go dark again before we move him forward again. So let's see. Oh, and we're also going to be pulling values from that light estimation script. So we need to instantiate we need to make a reference to that class, the light estimation class, here in this script. So let's see. After our AR camera, let's see. Let's just copy this. Copy and paste it again here. So we got the serialized field private, and then let's just change everything after private. Private light estimation, and let's call this light estimation. Okay. Now, let's see. Down here, let's create that bool that I was telling you about. So private bool on touch hold. And actually, we don't really even need this false. It's false by default. It's redundant. And the same thing here. Private bool previous dark state. So we're going to have dark state and the previous dark state. But we don't need to use a global variable for the dark state. We can just use a local one when we actually are doing the logic for it. All right, and then this code needs to be, you need to make sure you're doing it outside of this if touch greater than 0. Logic. Otherwise, it'll only work when you're touching the screen. That gave me about an hour of trouble last night before I figured it out. So make sure if you hover over a bracket, it'll tell you what the opening bracket was. And so that's the bracket we want. And you can also kind of look at this gray line and say, oh yeah, that's it. So we want to go outside of this bracket. And we want to only do this if the placed object is not null, meaning that we've already placed the monster. So if placed object does not equal null, then we're going to create a local variable called dark state. Var dark state. Oh, sorry. Var dark state equals light estimation dot is dark. So we're pulling that boolean that we set in the code, in the light estimation code, and we're saying we're pulling that boolean here and setting this dark state to whatever the current value is on is dark. Okay, and then we want to say if dark state, meaning if dark state is true and not previous dark state, meaning the previous dark state was false, meaning the last frame it was light and this frame it's dark, then do this. All right, so then we're going to move the monster. And we're going to move him, I think, 1/4 of the distance, of the current distance, closer to the camera. All right, so we're going to move him 1/4 of the distance closer to the camera. So first we need to actually measure that distance between the monster and the camera, and we're going to store that in a local variable called var diff posts, and we're going to do this with a vector3 dot. This is a cool function that I'm sure you will use again, called project on plane, meaning he will stay on his current plane. So he'll stay on the ground plane where we placed him, but we'll be able to transform him along that plane. So we have to give a, we need to use a project on plane, the camera's current position, AR camera dot transform. No. Transform. What are you doing? Come on. Transform. There it is. Dot position, comma, and then you have to define where you're projecting that. So the project on plane actually means you have the camera, for example. The camera is not going to be sitting on the ground plane unless you're lying on the floor and you have your camera right up against it. So what this is going to do is it'll project the position of the camera based on a vector that you define, and project that onto a plane, which will be below the camera. So this is project on plane, the camera transform position, and then the vector is just going to be the straight up and down vector. So we can just say that vector3 dot up. Okay, so that's that projection. Then we can say minus vector3 dot project on plane placed object dot transform dot position, comma, same thing, vector 3 dot up. So that will create the difference between those two positions and store it into a vector called diff posts. And now we can just change the transform position of the placed object dot transform dot position equals placed object dot transform dot position plus diff posts, and we're gonna do this 1/4 of the distance. So he'll close 1/4 of the distance between you, and you can do this forever, and he'll get incrementally, he'll move smaller each time. It's a logarithmic function. So as he gets closer to you, the distance that he closes every time you turn off the lights will be smaller. So divided by 4.0f. And because of order of operations, it will take the diff post and divide it by 4 first, and then add it to the transform position. And this will move it closer to the object. Now, the only thing we have to do is set this previous dark state. If we forget, then it's not going to work. We need to, outside of our if statement, we need to set our previous dark state equals dark state. Like that. Okay? And this var dark state is outside of the if statement too, so that local variable is available to set down here. But previous dark state, because it has to survive and still be readable on the next frame, we couldn't use a local variable here. We had to define that as a global variable up here. Okay? So that should work, and all we have to do now is drag in our references and change our placement object. So save, close, close. So go back to our place, drag, drop script. Why don't I see anything? Place, drag, drop. Well, there it is. Okay, light estimation. I need to drag that in there so I can drag the AR session origin. No, it's light estimation is in directional light. Drag in the directional light, and there's directional light. So that script is now working. Let me make sure the directional light doesn't have any empty values. It doesn't. Okay, great. Now the only thing we need to do is on our placed prefab, it's still set to dragon. Let's change that to character. So go to the prefabs in your assets here and go to monster and drag him in there. And that should do it. Let's go ahead and build this. All right, let's take a look at this. So, come on now. I got kind of not a lot going on the floor here, so it's kind of hard to scan. Come on, pick it out. Can't. My laptop. I'm tethered to my laptop, so I don't want to move down. Come on. Pick it out. I guess I'll pick up my laptop. Scan the floor. Scan the floor. There we go. Is it going to go to the end of the hallway? Close enough. I'll put them over there. All right. Let me set my laptop down. Okay. I can place the monster, and there he is. And you can see the brightness that I have in my brightness multiplier. I should be able to drag that and make him brighter to wherever I think. But because it's a multiplier, he still will go black when the lights go out. So there he is. Turn the lights off, and he gets closer. Lights off, closer. Lights off, closer. Ah. That's so awesome. All right, cool. Okay, there's just one more thing I'd like to do with this, and it's not really necessary. That's the script. I mean, that's the program. It works great. The only thing I'd want to do is maybe put some music in it, and I'll upload these samples that I'm using to the website. But let's see. You can go back into your Unity editor, and you can create an empty game object. We're going to call this background music. Hello. Why won't you rename? Whatever. BG music. And let me turn off the jazz music. All right, and we're going to drag in the scary violins loop into our assets. Actually, let's see. We need to, in our assets, let's make a new, no, that's the wrong assets. No, it's not. Let's make a new folder called music or sound. Actually, let's call it sound. All right, and let's drag both of these monster breath loop and scary violins loop into the sound asset folder. Now into your BG music, let's take a look at the scary violins thing first. Do we need to change anything here? No. All right, that's fine. Let's drag that into BG music. Now, if you click on BG music, you see this audio source. And by default, the sound is set to 2D, meaning it doesn't spatialize. And that's probably what we want for our background music. On the monster, we're going to add a source that does spatialize so that it's low volume when he's far away from you and high volume when he's close to you. So we can actually leave that one alone. And on the, go into your monster prefab. And probably on the mesh, I mean, it doesn't really matter where you put it, I guess. But probably on the mesh with everything else. Let's add the other sound, the monster breathing. So I'm going to drag that into body mesh. There. And now here I want to make sure I actually set this to loop. That's something I need to do on the other one. Set this to loop, and on the spatial blend, set this to 3D. Okay, so go back, and all right, so that's all we need there. Then go back to scenes, and our background music, we forgot to set that to loop as well. So set that to loop. Now there's one more thing that we need, or we don't hear any sound, and that is we need an audio listener, and you usually attach that to the camera. So here on the AR Session Origin AR Camera, go down to Add Component down here and click Audio and say Audio Listener. And that should be all you need to get sound in this. I wonder if you hear it when I hit play. Yeah. And if I put the monster in the scene, let's try that real quick. Drag him back a little bit. I'm going to move my camera up a little bit. Then if we hit play, That's the monster sound. And if we send the monster further back, it's quieter. And it should work that same way in your phone. All right, so that's all I wanted to show you guys today. And I'm glad we did it as a recording because I probably wouldn't have been able to get through all of this in a regular class anyway. So I'll reiterate, and I'm going to put this on the website. Again, let's just, to get this back to the way we need to, let's get rid of the monster and set the AR camera back to 0, 0, 0. There we go. So yeah, I'm going to put this on the class website, but all I want you to do, we're going to show our projects next week that we've been working on for the last 3 weeks. And double check the homework requirements on week 4 and week 5. I have them both in there, so you need to make sure that it fulfills all the requirements of both of those weeks, plus the requirement for this week, which is to add light estimation to it, so that if you turn the lights off, your object gets dark. Okay? You don't have to have it do this script that moves it in the dark. You don't necessarily have to place the lighting information on the screen, but you can if you want. It's definitely helpful for troubleshooting things. But if you just make sure that your object gets dark when the lights turn off, you'll be in compliance with the assignment for due next week. And we'll spend half the class probably looking at everybody's assignments. And let's see, next week, what do we have scheduled? Physics systems. I may change that, but maybe I'll change that to 2D tracking, because I think we rolled over 2D tracking this week, and we kind of already did some physics. Let's change that to 2D tracking for next week. All right, so next week we'll be doing 2D image tracking. Okay? And again, I apologize that last second I had to miss today's class, but I think we'll be in good shape if you're able to follow along on this online tutorial and create this dark monster game. All right, cool. Have fun. See you next week.